So we are just going to look at the shape of the interference curves. So first is min of x plus 2y comma 2x plus y. Okay. So utility equals to min of x plus 2y comma 2x plus y. Okay. So that's my utility function. So first of all, the first step is trying to figure out the boundary line. So where is the boundary? So utility function will be equal to the left part x plus 2y if x plus 2y is less than 2x plus y. Utility function is the minima of these two numbers. So it will report the left number if left number is less than the right number. Now if I can rearrange these things, I'll see this is logically equivalent to y less than x. Okay, so the upper statement is basically logically equivalent to this statement by cancelling out the x and y, x plus y part on both sides. So utility will be equal to x plus 2y if y is less than x. On the other hand, utility will be equal to 2x plus y if 2x plus y is less than x plus 2y, which is logically equivalent to x less than y. Okay, so now I can see that the division line, so I can compare these two things. I see that the division line is x equals to y. Okay, so one region is x less than y, other region is x greater than y, so the division line has to be x equals to y. So I'll draw the shape. My graph x y. Okay, uh, yeah, sorry, y and x, and then I draw a straight line from here. Okay, this is my x equals to y line. Okay. The right region, as I've already pointed out, is x greater than y. So here utility will be equal to, so remember that in the right region you have utility equals to x plus 2y. So utility will be equal to x plus 2y. Okay, in the left region you have y greater than x. So utility will be equal to, so in when y is greater than x, utility is 2x plus y. So utility will be equal to 2x plus y. Right? Now we can just take any utility number. I like to take the number 6 or 12, stuff like this, which is divisible by all possible, most of the prime numbers, 1, 2, 3, 4. Sorry, 1, 2, 3. So 6, 12, 15, such numbers are good because they are divisible by a lot of things, so you don't get involved in fractions. So suppose I take utility level of 6. So this equation becomes 6 equal to 2x plus y, and this equation becomes 6 equals to x plus 2y. Okay, now 6 equals to x plus 2y. How do I plot this curve? So I've already established how to plot any curve, convert it into y equals to mx plus c format. So 6 equals to x plus 2y. I want to convert it into y equals to mx plus c format. Okay, so when I do that conversion from here, I get y equals to minus 1 by 2x plus 3. Okay, so I'm taking y on one side, taking everything else on the other side, so you'll get this format. So slope of minus half and intercept of 3. So basically I am only interested in the slope part because I know that intercept will change depending on the utility value. I am mostly interested in the slope part. So here the slope will be minus half. Okay. On the other hand, here I am plotting 6 is equals to 2x plus y. Again I convert it into y equals to mx plus c. So y equals to minus 2x plus 6. So the slope value is minus 2. So I know that slope here is going to be minus 2. Now just compare the slope values. Here slope is minus 2. Here slope is minus half. Okay. So to the left side of my x equals to y line, so to the left side of my division line, slope is -2, so it's going to be steeper. So these lines are going to look like this, steeper lines. And to the right, slope is -1/2, so it's going to be a little flatter like this. And they are going to extend right to the axis. Okay, so they go and intersect the axis. So this is what the indifference curves will look like. They'll no longer be parallel to the axis now. So even though the division line is still x equals to y, my ICs are no longer going to be parallel. So you have to be able to do this entire process and find the indifference curves. It is something which has been asked multiple times in the entrance exam. So being able to draw these curves is very rudimentary. Okay, it won't be like you draw the curves. They'll just give you utility function, and uske baad we have to do utility maximization as well. So we have to be really quick about it, because within a matter of minutes we have to draw the curves and we have to do the calculations as well.